This is the Advanced Math Study Guide for Unit 3. Okay, I'm going to verify an identity, and when you verify identities, you need to make sure that you're changing only one side. It definitely makes it easier. I like to change the more complicated side, and in this case, the left-hand side to me looks more complicated than the right. Because of those parentheses, and I know how to remove parentheses. So I'm going to label this side the side that I'm going to change, and I'm going to keep this side. And even though I'm not going to touch the right-hand side, it's really helpful to think about what it is that you want, okay? So in this one, I know that I want a secant squared, and there is an identity that says 1 plus cotangent. Nope, it's tangent. I got that one wrong. Tangent squared theta plus 1. And there's another one for cosecant. And that one is equal to 1 plus cotangent squared theta. Okay, I like both of these identities a lot because this secant one from here gives me a tangent squared, and I have a tangent here, and I do have a square. It's in parentheses, but I can work with that. The other thing here, this cosecant here has a cotangent in here, which I have a cotangent here, and again, I have that square there. Okay, so those look very promising. So what I'm going to do now is I'm going to use FOIL to get rid of the parentheses. Okay, so I'm going to go tangent squared, oops, I should probably show you guys step by step. Okay, so tangent theta plus cotangent theta times tangent theta plus cotangent theta. And then I go tangent times tangent is tangent squared. Tangent times cotangent is tangent theta cotangent theta. Cotangent theta times tangent is again another tangent theta cotangent theta. And then cotangent times cotangent is cotangent squared theta. Okay, I notice here that I have two of the same thing. So I can combine those, and I would have 2 tangent theta cotangent theta. I see that I have that tangent squared that I wanted. Okay, so that's part of that identity. And then I see that I also have a cotangent squared, which is something that I wanted. So I can see that these are two things that I want to keep because those are related to what I want over here on this side. Okay. I am going to draw a little thought bubble around that little category there so don't get confused. Okay, let's change that back. Okay, so I know I need to get rid of the part in the middle, the 2 tangent theta cotangent theta, and so there is an identity that says tangent theta equals 1 over cotangent. And so I could plug that in here. And then I know that these two here are going to reduce to be 1. Okay, so when I clean that up a bit, I have tangent squared theta plus 2 plus cotangent squared theta. Okay, so I don't think I can do anything else. So now it's time to use those cotangent and cotangent squares. Remember, I have those identities up here. So tangent squared, yes, I want to use this identity, but the way it's arranged isn't really going to help me very much because I don't have a plus 1 unless I break apart the plus 2. So what I would do is use the other version of that same identity. Okay, and that one says tangent squared theta equals secant squared theta minus 1. I still have the plus 2. And then I would use the other form of the cosecant identity, which is cotangent squared theta equals cosecant squared theta minus 1. Uh-oh, wrong thing there. Okay, and now I can see that I have the secant and cosecant that I want, and I can also see that -1, 2, and -1 all end up canceling out, leaving me with precisely what I wanted. Actually, let me erase that. It looks really ugly. Okay, which was secant squared theta plus cosecant squared theta. Bring that other side down, equals secant squared theta plus cosecant squared theta. Final step. Okay, so I'm going to put this thought bubble here. Let's see, I'm going to keep it with this one here. So this is just all of like my brain power working that I'm vocalizing. It's not actually part of the identity, it's just what I'm thinking. Okay. Okay, so that concludes the first problem. Let's move on to the next one. Okay, for our next one, I want to do the same idea. I want to pick a side and leave a side. I see already that, let's go back to here. I have secant and tangent. And so I see that I have secant and tangent. They're not in the right spot, they're in the denominator. I also have another secant. So I don't really want to get rid of my secant and tangent. What I want to do is get rid of the denominator. So that's when you can use something called the conjugate. Okay, so I'm going to write that down. Conjugate, wrong one. The conjugate is used to get a sum or a difference out of the denominator, okay? So the conjugate here would be secant theta plus, plus tangent theta, because when I multiply that to this one here, I will get a difference of 2 squares, okay? And I'll come back to that. So I'm going to take that first side here, secant theta plus tangent theta over secant. Remember, any time you multiply something to the denominator, you must do the same to the numerator. Keep the balance. Okay, and so I can go ahead and distribute my numerator. And look, that's actually really nice because secant times secant is secant squared, and secant times tangent is secant theta tangent theta, which is what I want. So I still have to deal with the denominator. So when I FOIL that out, I'm going to get secant squared theta minus tangent squared theta. You could do full FOIL to get that, but you're going to see that the middle terms are going to cancel out. I know it's going to do that because it's a conjugate, and conjugates create sum and difference pairs. Now there is an identity on your identity sheet that says that secant squared theta minus tangent squared theta is equal to 1. So I can do that substitution here. And when I reduce that, I get exactly what I wanted. Make sure that your left and right sides are identical. Okay, final answer. Okay, and again, this is just my little thought bubble. Okay, let's move on to number 3. Okay, number 3, again, I want to manipulate one side. I see that I want a cosine. Okay, and which means I need to get rid of sine. Okay, so I do have a double angle here, which you have to be careful with. So a double angle, there's only one identity for that one, for the sine, and it says that sine 2x is equal to 2 sine x cosine x. So I'm going to substitute that in right there. Okay, and then I can see that I can eliminate my signs. And right away, I already have what it was that I needed. Excellent. And this is just my thought process. So on this next one, we're verifying an identity. So I can see on the left-hand side that this is a angle sum theorem. So be careful with that. Definitely look for it. I can see that there is an identity on my identity sheet that says tangent u plus v is equal to tangent u plus tangent v over 1 minus tangent u tangent v. Okay, and so looking at this, I have that plus sign. I have that minus sign. Okay, and then when I look at my angles, I can see that I have an angle here and here that are the same, and I have those same angles there. Okay, and then here I have angle B, and that matches here and here. So now the goal is to work it backwards so that it looks like this part in the top up here. Okay, so I know my U and V. Uh-oh, wrong one. U, V. Okay, and so I'm going to plug those in there. So I would have tangent of 3x plus x is equal, and then tangent, when I actually add them up, tangent 4x is equal to tangent 4x. Final answer. I like that. I like my typical little, there we go. Okay, next one, I still want a secant to the fourth. Okay, so I know I want to keep somehow, maybe combine them. In fact, I can think of a way right now to combine them. If I factor out the secant squared, which is our GCF, then I would have 1 plus tangent squared theta. And that's really wonderful because there is an identity that says secant squared theta is equal to 1 plus tangent squared theta. So I'm going to plug that in here. And then this magically gives me exactly what I want because we add our exponents. Done. Again, this is just my little thought bubble here. Okay, and I used that substitution to go right there. Okay, all right, next one. Next, okay, here I have a very simple right side and a much more complex right side. I can see that the cosecant is really the only thing I want to keep here because it matches the other side. So somehow I have to get rid of the sine and the cosine. So it helps sometimes to think about what this might be. So I know I want this back, but right now I don't see any way to factor or do anything without temporarily changing that. Okay, so I'm going to use this identity here. Cosecant x is equal to 1 over sine x. And normally I wouldn't change that because I know what I want, but I just don't see anything else to do right now. So I'm going to have my sine x plus 1 over sine x times cosine squared x. Okay, and let's see. I do see that I could rewrite this as a fraction here. Sine x plus cosine squared x over sine x. I somehow want to now combine these two. So I'm going to multiply this fraction here by sine x over sine x. That'll give me sine squared x plus cosine squared x all over sine x. And I really liked that because sine squared x plus cosine squared x equals 1. And then I can see that I'm getting my endgame back because right here I have that cosecant. Now, in reflection, seeing how I got to the end there, I'm thinking I probably could have done this faster, but how could I have done it faster? I think what I probably could have done is done a substitution right away here and gotten my sine, used the 1 minus sine squared theta and then multiplied by that cosecant. I think I might have been able to do it faster. So there's definitely more than one way to do these problems. Okay, we have another verify the identity. There aren't that many of them on the test, but it's nice to work it out. Okay, so this one has two different ways. I could do the conjugate thing again, or I could change my numerator. Okay, so I am going to show you changing the numerator. And so there is an identity that says cosine squared x is equal to 1 minus sine squared x. So I am going to substitute that into my numerator here. And then the problem here is a lot of times students will just want to cancel out the sine and the 1. You can't do that. You have to factor the numerator in order to cancel by division. So that would be 1 minus sine x times 1 plus sine x. Okay, and then I have my 1 minus sine x in my denominator. So those I can eliminate, leaving me with 1 plus sine x on the left, which is equal to 1 plus sine x on the right. Final step there. Okay, but just remember you have to factor that numerator. Okay, so I'm going to highlight that. Uh-oh. Let's see if I can erase that little bad boy. There we go. I wanted to say to reduce. Okay, and again, that's just another thought I wanted to share. So it was a common mistake some of you are making. Okay, next one here. It's another verify the identity. Okay, I can see that I want to get rid of all of that and just end up with a 1. Okay, so there's definitely no double angle, so I want to get rid of the double angle. There are several here for the double angle identity for cosine. There's cosine 2x equals cosine squared x minus sine squared x. There's one that says 2 cosine squared x minus 1. And there's another one that's 1 minus 2 sine squared x. So right away I can see that if I use this last one here, I would have a negative 2 sine squared x, which would cancel with the other one. So I'm going to use that substitution here. And I have 1 minus 2 sine squared x plus 2 sine squared x. Those will wonderfully cancel, leaving me with 1 equals 1. Final answer. Sweet. It's way easier than it looked like, huh? Okay, the next one is we're solving on an interval. This one wants degrees. So very, very important to look at the instructions. There's 2 in the open response section that are going to ask for degrees. So the first thing you want to do is isolate your trig function. And divide by 3. To get rid of the square, we square root. But don't forget, when you square root, you get your plus and minus. Square root of 1 is 1. Square root of 3 is root 3. Okay, so cotangent is positive in quadrants 1 and 3, negative in quadrants 2 and 4. Okay, so you can look at it as unit circle coordinates or triangles. Okay, either way you're going to get the same thing. I like to think of it as a triangle because it's a little harder to visualize when we're not using it, I think. So x over y, so my 1 is an x, my y is a root 3. I can tell that this is a 60-degree triangle, but for those of you who aren't seeing it, let me draw this one. You can do your Pythagorean theorem, and so that would be 1 squared plus root 3 squared equals r squared. Okay, and that would be 1 plus 3 equals r squared. 1 plus 3 is 4. Square root both sides, and I get an r value of 2. But remember, we want to reduce our triangle, and so if I divide everything by 2, I get a similar triangle, but it gives me that coordinate there. 1/2 comma root 3 over 2, which is our 60-degree triangle. Okay, so my first quadrant 1 answer is 60. This is 60 in each one of these, so a 180 minus 60 is 120. A 180 plus 60 is 240. And then 360 minus 60 is 300. Final answer. Okay, so in solving this, I'm going to add 1 to both sides. Let's make sure my right pen on here. Okay, so add 1. 3 cotangent squared x is equal to 1. I'm going to divide both sides by 3. And I'm getting cotangent squared x equals 1 over 3. I'm going to square root. I get cotangent x equals plus or minus 1 over root 3. Okay, and there's a couple of ways you can go about doing this. Some of you see this from the unit circle right away, others don't. So I'm going to go ahead and sketch out the one in quadrant 1. I know that cotangent is the x over the y value, so that would be 1 and root 3. You can use Pythagorean theorem to find your hypotenuse, so I'd say 1 squared plus root 3 squared equals r squared. That gives me 1 plus 3 equals r squared, or 4 equals r squared, giving me an r value of 2. Now, this is a reduced value, or this is not a reduced value. When we use our unit circle, we use reduced values to make them more recognizable. But if you just divide everything by 2, that gives you that radius of 1, and now it's easy to see what triangle this is. So because we want degrees, the angle opposite the root 3 over 2 is 60. Okay, and now we're going to find that in all 4 quadrants. Okay, that's where my reference angle is 60. Okay, so I have 60. 180 minus 60 is 120. 180 plus 60 is 240. And then 360 minus 60 is 300 degrees. Okay, highlight that. Okay, next one. Okay, so for these next few, we're finding solutions on the interval 0 to 2 pi. So that means we need all of our answers to be in radians. Here. Okay, so change my pen color here. I'm still going to isolate. I'm going to add my 2 to both sides. I get to secant squared x equals 2. Divide both sides by 2. I get secant squared x equals 1. And then when I square root both sides, I get secant x equals positive or negative 1. This is a quadrantal. Remember, it's r over x. So it's where our x value is 1 and negative 1. And x values are 1 and negative 1 at these 2 locations. So my answers are 0 radians and pi radians. Final answer. Okay, let's see, try to get to our next one. Okay, so for this one we have trinomial factoring. So I'm going to have 2 cosine x minus 1 times cosine x minus 1. You should check your factoring there. You set each factor equal to 0. And this one I isolate. Not a sign here. I have cosine x equals 1, divide by 2, and I get cosine x equals 1 over 2. Here, when I add 1 to both sides, I get cosine x equals 1. So I have a quadrantal and a quadrant 1 and quadrant 4 angle. This one here would be 1/2 comma root 3 over 2, which is a pi over 3 angle. And that quadrantal right here is at 0 radians. So my answers are 0, pi over 3, and the quadrant 4 angle would be 5 pi over 3. Next one, this one had a typo in it, so let me point that out for you real quick. Here there was a plus sign on the original, and I'm changing it to a minus sign because it didn't work before. So once you have that, then you're going to use a double angle identity. And it's because you don't want to have cosine 2x and then sine x, okay? You really want them to be a match. And so the double angle identity that I'm going to use is 1 minus 2 sine squared x. And that's because this one here has a sine in it, so that I know I can do some factoring here. And the other ones have a cosine squared in them, and that's not going to help me with factoring at this point. Okay, so now I see that with this correction and that typo, those two will eliminate. And then I'm left with negative 2 sine squared x minus 2 sine x equals 0. I'm going to factor out my GCF, which is negative 2 sine x. Okay, and I set each factor equal to 0. Divide by negative 2, I get sine x equals 0. Add 1, I get sine x equals 1. Okay, and then I have my quadrantals here when y is 0 at 0 and pi, and positive 1 up here, but I did make a mistake. I just saw it. Okay, so when I factored out that negative 2 up here, I should have had a positive 1. So that'd be positive, subtract 1 on both sides. So I do need to change that one there. It would actually be down here at negative 1. So my answers are 0 radians, pi radians, and 3 pi over 2 radians. Because the interval says up here, that curvy bracket, it means you pick 0 instead of 2 pi. Okay, the staple bracket means you're using 0 instead. Okay, I don't think that one's on the test anyway. Okay, let's try this one right here. Okay, so I'm going to use another thing to get rid of that double angle. There's only one double angle formula for sine. That's 2 sine x cosine x. Okay, so I'm going to plug that in here. Okay, so I'm going to have 2 sine x minus cos. Oh, take it back. Oh, no, that's right. Oh, cosine. Okay, so again, I just substituted not all of that. Hang on. I only substituted that part in there. I can clean that up a bit, and I'd have 2 sine squared x cosine x minus cosine x equals 0. Again, I think I have another typo. Darn it. Okay, I would factor out my cosine. And when I factor out the cosine x, I would have 2, 2, I switched the color of my pen. Okay, so that would be 2 sine squared x minus 1 equals 0. I set each factor equal to 0. Okay, I can see, I think this is going to work actually. Okay, so this one as a quadrantal, I'll solve that one in a minute. I'm going to add 1 to both sides. I'm going to divide both sides by 2. Okay, so then I need to square root both sides. That's going to give me sine x is equal to positive or negative 1 over root 2. If you rationalize your denominator, you'll get positive or negative root 2 over 2. So that actually does work. Okay, so then when I'm looking at those angles, cosine is 0 when the x value is 0 here and here. Okay, and so that means I'll have one at pi over 2 and 3 pi over 2. And then root 2 over 2 is when the sine is 45 or pi over 4. That'll be this coordinate here. Okay, so that would be pi over 4, comma, pi over 2, comma, 3 pi over 4, comma, 5 pi over 4, comma, 3 pi over 2, comma, let me erase, move that over a little bit, comma, 7 pi over 4. Put that square root back in there. That's my final answer. Ooh, so no typo, but hard one. Okay, that might be in the challenge section of the test. Okay. All right, so for 15 through 18, we're using sum and difference formulas. And so I see here sine and cosine. And so I'm reminded of this identity here that says sine of u plus v is equal to sine u, not plus, times cosine v plus sine v cosine u. Okay, and this looks like a really good match because I have an angle u here that shows up here and here. And that same angle here shows up there and there. So I'm going to say angle 20 is u. Okay. All right, and then here, if I look further, I have an angle here, angle V, that pops up here and here, which gives me angle 40, because that pops up also. Okay, so my next answer would be sine of, my U is 20, plus my V is 40. When I add those, I get a 60-degree angle. And sine of 60 is in quadrant 1. It's this ratio right here. So my final answer would be root 3 over 2. Okay. Alrighty, and then this one here, again, we're doing sum and difference, but this time we're going from the angles, and we're going to try to get a ratio, okay? So here I have my formula. Tangent u minus v is equal to tangent u minus tangent v over 1 plus tangent u tangent v. Okay. And here I can see that the 45 is going to go where all of the u values are, and the 30 is going to go where all the v values are. Okay, so let's plug those in. I'm going to have tangent of 45 degrees minus tangent of 30 degrees over 1 minus tangent of 45 degrees tangent of 30 degrees. When you look at a 45-degree angle, that gives you your root 2 over 2. So tangent of 45 is equal to 1. Tangent of 30 is dealing with this one here, root 3 over 2, 1/2. so tangent of 30 degrees is equal to 1 over root 3. Okay, so I'm going to plug those in. 1 minus 1 over root 3 over 1 plus, that's a plus sign in the denominator, plus 1 times 1 over root 3. Okay, now I don't need to have the 1 here. So I could say that this is a final answer, but it's a complex fraction. Okay, so here, this would be the complex version of that. So sometimes students will simplify that. The complex fraction I multiply by root 3 over root 3, and that would give me 1 times root 3 is root 3 minus root 3 over that would be minus 1 over root 3 times, that would be, give me a 1. Okay, so that's a simplified version. Let me erase this one. Okay. And then there's actually a rationalized version, and that would be by multiplying this by the conjugate. Okay, so I know it sounds kind of crazy, but I would multiply by root 3 minus 1 and the top and the bottom. That'd give me a difference of 2 squares in my denominator, and that would be 3 minus 1, which is 2. Okay, here. And then I would have that multiplied up here, so that'd be 3. Root 3 times root 3 is 3. And then I would have negative 1 times root 3, negative 1. So it'd give me negative 2 root 3, and then a positive 1. Okay, so I'd end up with a 4 minus 2 root 3, and then I divide everything by 2. So I'd end up getting 2 minus root 3, and that would be a rationalized version. Okay, and so I'm going to write that down real quick, just in case you were trying to match it with something in the back of a book. Okay, and that's it. Okay, next one, we're using sum and difference formula. That's a big hint for you. Okay, so the sum and difference formula for sine says sine of u plus v is equal to sine u cosine v plus sine v cosine u. Okay, so I just need to find two numbers, u and v, that add up to be 150. So here are the angles that we have to work with. In degrees, those would be 30, 45, 60, and 90.
Attention teachers, the CSU application workshop is going on right now in the Career Center. If you have a senior with a red pass, can you please send them to the Career Center with their last name ending A through B? Thank you.
Okay, so I do see a combination. That would be my 45 and my 60. So I'm going to say sine of 45 degrees plus 60 degrees. I got that little extra line in there. Okay, and so I'm going to go sine of 45 times cosine of 60 plus sine of 60 cosine of 45. Okay, so when you look at that 45-degree triangle, that is your root 2 over 2 comma root 2 over 2 coordinate. So for sine, that's root 2 over 2. Then cosine, I'm looking at the 60-degree triangle. Okay, so 60, that's where you have the 1/2 for the cosine and the root 3 over 2 for the sine. So I need the cosine here, so it's 1/2 plus sine of the 60 is root 3 over 2. Cosine of the 45 is root 2 over 2. Okay, and let me do a little highlighting just so you can kind of see where I'm getting those. So 45 here. Okay, and then here when I'm doing my 45 on, let me see, let's change my color here. this 45 here is coming from here. Okay, and then my others are coming from, let's see, let me do a green one here. My cosine 60 is coming from the 60 triangle, 1/2. Okay, and then my sine, this is not really a different color, but orange, I guess it's a little different color, is coming from that one there from my 60-degree triangle. Okay, so now I'm just going to multiply and clean it up. So root 2 times 1 is root 2. 2 times 2 is 4. Root 3 times root 2 is root 6. And you cannot reduce any of it. So this is my final answer. Okay. Okay, same idea, sum and difference formula. This time I have cosine. And I am going to use a subtraction, but I'm going to write it down as the positive and then how to change it. Okay, so it's u plus v equals, I like this one the best when evaluating because then I don't have to add or subtract 1. Okay, and that's easier for me. Okay, so your angles here are going to be pi over 6, pi over 4, pi over 3, and pi over 2. So, but I have a pi over 12 here. So I multiply this one by 2 over 2, and I know that this one is equal to 2 pi over 12. And I multiply this one by 3 over 3, and I get this one is equal to 3 pi over 12. Okay, right away I can say I can stop right there because 3 pi over 12 minus 2 pi over 12 will give me pi over 12. So I am going to subtract. Hey!
Hello. This is for unit 3.
Okay.
And it's late.
Okay.
That exponent practice, that one was due yesterday.
I can re-release it. Just remind me in class today.
Okay. Because it's 100 points and it says
yes.
it's late.
Well, it's only 10 points, but it says 100 because it's out of 100%. Yeah. But yeah, just remind me and I'll redirect you to that today in class.
Okay.
Yay, you got it. Thank you for this. I'll try to get that in for you today.
And then when are we taking 3C or did we take it already?
3C, target 3C.
It said it's not graded. Yeah.
I have to look. I'm not sure. Is this one right here? We've only done one, so it's probably not going to go in for a while.
Okay.
Yeah.
I'm really trying to get a B in here.
Yeah, you got to work pretty hard.
Yeah,
I've been a little concerned. Here, let me pause this because I'm doing a video right now. Sorry about that. I had a student pop in. Okay, so minus 2 pi over 12. So here I know I'm using a subtraction, so I'm going to adjust that one. It says minus, and then when there is a minus sign, ooh, that's not even the right identity. I don't think. It would be cosine of u, cosine of v minus sine of u, sine of v. Okay, I was using a double angle identity, and that's not a double angle for sure. Okay, so, oh, but it's a plus. So on the formula, these are always opposites for cosine. So my u is going to be the 3 pi over 12. My v is going to be the 2 pi over 12, but those don't look like angles from our unit circle, so I'm going to convert them back to these ones here. Okay, so that one's equal, this one's equal. Okay, so I'm going to do pi over 4 minus pi over 6. Okay, and then this one is my 45-degree triangle. So cosine of pi over 4 times cosine of pi over 6 plus sine of pi over 4 times sine, not cosine, of pi over 6. Oh, that 6 does not look like a 6. Okay, so the pi over 4 triangle or unit circle is the one with the root 2 over 2. Okay, and then the pi over 6 triangle is the one with root 3 over 2 and the 1/2. Okay, so the cosine is always the x value. So this one is root 2 over 2 times root 3 over 2 plus, and then the cosine is root 2 over 2, and of the pi over 6 is 1/2. Okay, so I get root 6 over 4 plus root 2 over 4, and when I combine them, I get root 6 plus root 2 over 4, no reducing. That's my final answer. But that 4 looks wonky, so let's fix it. Okay. Doot doot. Oh, that looks ugly. Dang it. Okay. Next. Okay, these you are doing so good in class. It says use the double angle identities. Okay, I really don't like 16. I wish I hadn't put that one in there. It's harder than what it needs to be, but I'll show you it. Okay, so here it says double angle formulas. So the double angle one for cosine, there's one that looks just like this. It says cosine of 2u equals 2 cosine squared u minus 1. So notice this looks like exactly the same. I have a 2, I have a cosine squared, and I have a negative 1. So that means that my 50 is my u, and so I'm going to plug that in right here. Okay, so that's going to be cosine of 2 times 50, which gives me cosine of 100. It says to rewrite it as the sine or cosine or tangent of an angle. That means we're done. It does not say evaluate or give exact value. Okay, final answer. Okay, 16 I don't love, and that's because the double angle identity says cosine of 2u equals cosine squared u minus sine squared u. So see how the negative's in the wrong spot? So if I take the negative out, then I would have cosine squared 1x minus sine squared 14x. And now I see that I have, oh yeah, this part is exactly the same as this part. Take it back. I don't know what I was thinking there. This would be cosine of 2u. Sorry. And then here I would go, okay, cosine squared. That shows up right here. And then sine squared shows up right here. The minus sign's even in there. So that means that our u is our 14x. Okay, so I'm going to plug that in right here. I still have that negative. Cosine of 2 times 14x, and that gives me negative cosine of 28x. Final answer. Okay, here this looks just like the double angle identity sine of 2u equals 2 sine u cosine u. Hello? Hello? This is Melissa. All right, sorry about that. I had my doctor call. My appointment tomorrow. Yay. Not so much. Okay, anyway, so I see here that I have a 2 and a sine, which is exactly what I have here. And then I have a cosine, which is exactly what I have here. So that means that the u here and here must be 12. So I'm going to plug that in right here, and I'm going to end up with sine of 2 times 12 degrees is equal to sine of 24 degrees. Final answer. Okay. Next, okay, so this one threw a few of you off when we were studying this the other day. So, even though the lesson you guys did super great. So we did do these in some Cornell notes for objective 3.4, so definitely review those if you have questions on this. I can see it's using an angle difference formula, and so the one for cosine says cosine u cosine v plus, those operations are opposite, sine u sine v. So in order to do that, I'm going to need to draw some triangles, because here I'm given the sine u, but I don't have cosine u. Okay, so I'm going to draw a triangle for each. They're both in quadrant 2. Okay, this will show up as Pythagorean triples on your formula sheet. So this one, your y is 5, 13. Nope, 13 is the hypotenuse. And then that would give me a negative 12, because it's a Pythagorean triple. Okay, so I'll write that one down. It's a 5, 12, 13. Okay, and then over here we have a negative 4 and a 3, so that would be 4. The negative has to go here because that's where our x's are negative. This is a 3, 4, 5, and so this would be 5. Okay, let me label it with my angles u and v. So when I do my cosine, I am using this triangle here for the u, and I'm going to use that one for the sine u. Okay, so let's do that real quick. So I'm going to get equals cosine of u is negative 12 over 13. Okay, I'm going to leave a little gap here, plus the sine is 5 over 13. Okay, and again, I just took care of that part right there. Okay, but now I got to do the other one. And so the other one here is my cosine v and my sine v, and those come from triangle V. So I'm going to say cosine of v is negative 3 over 5. And then sine of v is 4 over 5. Okay, and then I'm just going to multiply and clean it up. Okay, and again, I got this one and this one from the V triangle. Okay, so negative 12 times negative 3 is positive 36. 13 times 5 is 65, plus 5 times 4 is 20 over 65, giving me a final answer of 56 over 65. Okay, now keep those triangles in your memory, because I believe those are going to show up on the next one. On your study guide, I think it's all on the same page, so it works. But for me, I'm presenting, so it's huge. Okay, so I'm going to redraw those triangles again, just so I have them on the screen. So 5, 13, negative 12, that's triangle U. 4, 4, 3, negative 5. Okay, so then sine of u plus v, the formula says sine of u cosine of v, plus the operations are the same for sine. Sine of v cosine of u. Okay, again, I'm going to use for my u triangle, I'm going to use that one for this one and this one. Okay. And so I'm going to have sine of u is 5 over 13. I'm going to leave a space there. And I'm going to leave a space there. Cosine of u is negative 12 over 13. This came from triangle u. Here, though, for the v, I'm going to use my v triangle, which I forgot to mark here. Okay, so I'll mark it with a v. Okay, so that's going to give me this value here and this value here. Okay, so cosine of v is negative 3 over 5. Sine of v is 4 over 5. And then I can multiply, giving me negative 15 over 65 plus negative 48 over 65. And when I add those negatives, so 5, and that's going to be 3. Carry the 1. 4, 5, 6, negative 63 over 65. I believe. I hope so. I'm gonna check my answer just because I did that. Arithmetic in my head, and we all tend to make mistakes if we do too much in our head, especially when we're working that hard. Okay, so I know I got the 56 over 65 correct. I'm not seeing that other page in here. Page 5. Ah, there it is. Yep. And it's negative. Yep. Okay, good. All right, and it looks like in the next one we're using the same triangles. So I'm going to draw them again really quick. Okay, so my triangles here are -3, 4, 5 for V. And then this one was 5, 13, -12. Okay, so sine of 2V, I'm only going to use this triangle here. Sine of 2V equals 2 sine V cosine V. Okay, again, I'm only using the V triangle. This one. Okay, for this one and this one. Okay, so this one I'm going to go 2 times 4 over 5 times -3 over 5. And 2 times 4 times 3, that would be -12, -24. 5 times 5 is 25. Final answer. Okay, and that's what I got for last year. Yes. Okay, one more like this. Okay, number 21. Okay, so again, those triangles. You don't have to draw them repeatedly on the test, by the way. I'm just doing this because I can't see the other page. Okay, so cosine of 2u, my favorite to use for this is the cosine squared u minus sine squared u. You can use the others, but then you have to subtract 1 and add 1 or whatever, and it's kind of crazy. So cosine of my u triangle, I'm only using this one. Okay. So I would have my -12 over 13 squared minus my 5 over 13 squared. A -12 squared is 144, 13 squared is 169, minus 5 squared is 25, 13 squared is 169, and I believe that's 119 over 169, final answer. Okay, and I think that concludes the study guide. Let's see if there's any more pages.